In this set of lectures, we will take a look at three different topics. They're all related. They're class inheritance, polymorphism, and abstract classes. Inheritance and polymorphism go together, and maybe some of you have seen abstract classes, but maybe some of you haven't. It doesn't really matter if you haven't, because I'll introduce abstract classes at a very basic level, and then we'll see more of it later in the semester. So these are all topics that I hope most of you have probably seen before, at least some of it. Okay, so inheritance is also referred to as an is-a relationship. So we say a class A can be considered to be or is a some other class. An object A is a object B, for instance. So that's inheritance gives you that kind of a relationship. We'll get into that soon. In Java, we have single inheritance. That is, you have a subclass that extends or is derived from an existing class, which is the superclass. So the existing class is called a superclass, and then you create a new class. Class A extends an existing class, the superclass. So class A would be called the subclass. Whatever it extends is the superclass. In many other languages besides Java, you can have things like multiple inheritance. That is, a subclass can be derived from more than one superclass. This is not supported by Java, for a good reason. We'll get into this when we get to maybe other languages, like in future courses. Like C++ is a language we will look at in a future course, maybe, if those of you take data structures. And in a class like that, in a course like that, you would use C++, where you can have multiple inheritance. But luckily for you, Java does not support multiple inheritance. You can avoid a lot of maybe unneeded complexity. In Java, a class can only extend the definition of one class. Turns out there is a sort of limited form of multiple inheritance, in that when we get to interfaces, you'll see that a Java class can implement many interfaces, more than one interface. So there's a limited form of multiple inheritance, but strictly speaking, Java is a single inheritance language. Okay, so you might say, well, what's going on here? If you have a class shape, and then a class circle, class rectangle, is this multiple inheritance? Well, no, because you can have many classes extend a superclass, but each class can only extend one superclass. So circle extends the shape superclass in this case, and rectangle also extends the shape superclass, but circle does not extend any other classes. Neither does rectangle. Okay, so you've seen this kind of structure before. You say class, whatever, circle, let's say, extends shape, and then you can have modifiers like public, class, circle, extends the class name, and so on. So you can have static and all that, and then inside this you have just a bunch of members, that is data members and method members. That is instance variables or class variables, those would be the data members, and then methods would be the method members. Okay, so as you know, there's all these different terms that refer to the same thing. In these set of notes, we say derived. That is another way of saying extends. That's another way of describing inheritance. So extends is the same as derived. So in this previous UML diagram, well, this is sort of UML, we say that circle extends shape. Another way of saying it is that circle is derived from the shape class. Class circle derived from the class shape. Okay, and so let's take a quick look at an example that I've set up. So I've set up a shape class. Here it is, very sort of basic. It has two data members, perimeter and area. And no constructors for now. We just sort of decided we didn't need shape constructors. And we have a get method for each one of these data members. So then we said set up circle. Circle, this is what circle looks like. Circle extends shape. It has a data member for radius. So circle has basically just one thing describes a circle. It's the radius. That is assuming that we don't have to position the circle anywhere. We're just worried about the size of circles. And we have a constructor for circle, and we have a set radius method. So very simple class. Here's a simple class that extends shape. Now would you want to do this? Well, there's probably a lot of reasons you shouldn't do things this way, but this is all we really need. And so you can do things like this. You can say shape S is equal to new shape, and then you can say circle C is equal to new circle. So this use shapes is the client class of both circle and shape. So here's circle, here very simple, just one data member, keep it nice and simple. Shape has two data members. The idea being that if you take a look at all these classes, circle, rectangle, square, what do they have in common? They all have an area. They don't all have a radius. Circle has a radius, rectangle and square, they don't have radii. They would all have an area. They would also have a perimeter. So we put those common things into shape, and then the things that are like individual to or particular to each one of these classes, like radius would go into here, rectangle would have a length and a width, and square would just have either a length or a width, basically a size. So that's the kind of thing that you typically do. Now there's a lot of things that are probably need to be different about the example that I set up, but that would be a reasonable first start, and I'll show you that we would probably want to do things slightly differently. Once we know how abstract classes work later on in this set of videos, we'll see that probably want to do things differently. So here's the shape again, circle. Now let's take a look at rectangle. Rectangle has a length and a width, and then you might notice I made this protected and not private. Why is that? Because for a first try, we might want to say that both length and width should be visible to a subclass. So now that's how you make things visible to a subclass, directly visible. If I had made this private, then the square method would not be able to do this, would not be able to assign values to it. So by making length and the width protected, the subclass of rectangle, that is square, cannot change or cannot directly access a length or width. So one way to get around that is to make this protected, but as I'll show you later, this is probably not necessary. You can make these private and still allow the square class to initialize it. And how can you do that? You can do that through the constructor, things like that. So a square, when you set up a square object, you don't have a length and a width. Well, you do, but they have to be exactly the same. So that's how you would enforce. This is the kind of thing you would do when you have a set size method, let's say. You would set length is equal to width is equal to s. What that does is copy this value s into width, and this whole thing evaluates to a single value, which is the value that you put into width, basically s. So this is the same as saying length is equal to s, width is equal to s. Okay. So that's a quick look at a first try at implementing this inheritance scheme. It's not just one class inheriting from another, it's two classes inheriting from shape and then square inheriting from rectangle. Okay. So here are some rules about visibility. The private members of the superclass are private to the superclass. The subclass cannot see private members of the superclass. Now what does that mean? Basically that means in our example if I were to make this private, and let's make them both private, and you start to see, you should see probably a bunch of errors pop up in Square. So now that length and width are private in the superclass, I cannot read them, cannot write to them. So this is writing the value size into both of them. You cannot do that anymore. Okay, so remember, you always want to make things private unless there's a really good reason not to make it private. Sometimes when you have inheritance, you might be justified in using something like this, protected. Why? Because as soon as you make something protected, your subclasses would be able to access length and width as if they were public. But to classes that are not related to rectangle, protected is the same as being private. So if you're some other client class that's outside this package even, then any rectangle object that you might have, the length and width data members would be just as invisible as being private. Okay, so there are some things, there are some fine points that you have to consider, but that's the basic picture. So private members of the superclass are private to the superclass. They are not visible to subclasses. A subclass can directly access the public data members of the superclass. Now you might say, well, what about protected? Well, we're not really getting into protected right here. I just showed you in the code that you can use protected, but yeah, a subclass can directly access public data members of the superclass. It can also access protected data members of the superclass. And we'll get into more of those invisibility rules later. A subclass can include additional data and members. So we saw that here. Let's go back way back to shape. Shape has these private data members, perimeter and area, and circle adds its own. Basically it has, because it extends shape, it has an area and a perimeter, and then it adds another data member, in this case radius, rectangle. In addition to having those area and perimeter, which it cannot access directly, even though it does not cannot access it directly, you still have them. So any rectangle object will have an area and a perimeter. And in this case, a rectangle adds two of its own data members, length and width. Okay, so subclasses can have additional data and method members. And the subclass can override or redefine the public methods of the superclass. Let's take a quick look at that. One thing that comes in handy, as you all know, is toString method, which I have not set up. So if you had a toString method in shape, you could override that. Typically that's what you would do, is you would override it in circle, you would override it in rectangle. So I don't have one, but you could do that. Actually, in this case, I'm not overriding anything. And you could override it in square. Later on, you'll see an improved version of these classes where I do use overriding of toString. Okay, so just to show you this particular code, if you run this, take some time because I'm doing some other processing in the background. Oops. All right. There it goes. Okay. So without a toString method, you see that the shape S has, and it's printed using this package name, class name, and then a hash code and all of that. So if you have access to this code, definitely run through this, step through it, and see why it's printing what it's printing. The hash code stuff, remember, we can change that with a toString method. We'll do that later.